This is Mr. Barnett, and this is a video lesson on correlation and causation. In this lesson, you will distinguish correlation, which we saw in the last lesson, from causation, and you're going to evaluate conclusions which are drawn from scatter plots. Remember, we saw how to create scatter plots in the last lesson, but now we have to think, what can we conclude from a scatter plot? What can we reasonably conclude, and also what can we not conclude? So let's go ahead and get started and take a look at our example from class. We looked at home prices and violent crime. We wanted to see what is the correlation or the relationship between the home prices in a ward and the rate of violent crime which we see in that ward. And we had two theories here. We had the Barnett theory and the Hall theory. So the Barnett theory, let me start over here, says that the independent thing here is crime on my x-axis. The dependent is the price of the home. In other words, the home price depends on violent crime. Mr. Hall saw the exact same data, and Mr. Hall said, no, that's the other way around. If there are low home prices in a neighborhood, that's independent, and the crime rate depends on the value of the homes. And if I wanted to sum up these two things, I would say this. The Barnett theory is crime causes low home prices, high crime, low home prices. And Mr. Hall says low home prices cause crime, low housing prices, high crime. So both of these theories seem sort of plausible. Can we tell who is right? And the answer here is that we cannot tell who is right. We see a trend that home prices are related to crime, but there's no evidence from these scatter plots that one causes the other. They're related, but we can't tell that one causes the other. And this leads me to an essential point, which is that correlation does not imply causation. Two things being related to each other does not mean that one causes the other. So crime and home prices are related. It doesn't mean that crime causes home prices, and it doesn't mean that home prices cause crime. What Mr. Hall and I have are theories, but they're not proven. There are a couple reasons why two things may be correlated, two variables. Well, in some cases there may be causation. It is possible that one of us is right, that crime causes low home prices, but a scatter plot can't show us that. We need an experiment to show causation. Another possibility is something called a lurking variable or a common cause, which affects both. So someone might say, well, it's not crime causing low home prices or low home prices causing crime. They're both caused by the same thing, which might be poverty. Poverty leads to low home prices, and poverty leads to crime. Or they're both caused by a lack of education, or they're both caused by racism, or something like that. So there may be something else going on behind the scenes. And sometimes there's just coincidence. A while back, someone said if the Redskins win on the game before a presidential election, a Democrat would win, and if the Redskins lose, a Republican would win. And that actually held true for about 80 years. It didn't have to do with causation, it was just coincidence. Here's my favorite example. This is a scatter plot that shows ice cream sales and shark attacks. Ice cream sales are here, shark attacks here. What sort of correlation do you observe? Well, there's a pretty strong positive correlation. So I'm wondering, does this mean ice cream sales cause shark attacks? Well, no, that doesn't really make sense. What's going on here, I think, is a lurking variable. In the summertime, ice cream sales go up and shark attacks go up. So there is a relationship due to the weather, but there's not cause and effect here. So always remember, correlation is not causation. And if you see someone with a scatter plot saying one thing causes the other, well, that is not the case. It shows a relationship, but not cause and effect. And that's essential to keep in mind.